Okay. All right, so guys, welcome to 8B, the lab. So today we're just going to go over some introductions. So I'm going to share my screen a bit. So I've made a little presentation, so more visual aid for you guys. So here is what's on the agenda for today. So we're going to do some introductions. Then we're going to go through a safety discussion. So we're going to go through that website together as a class. It's required, so just bear with me. But you're required to complete it and submit the assignment online. So you just watch along. You can do it later on your own really quick. Don't even have to watch the videos again. Then you'll be good to go. So make sure you do the safety discussion. It'll be counted as probably points on participation. Then we'll talk. I made a few slides about experiment 1, give you some background information, some review. So hopefully it's stuff you still remember from 8A. Okay, so introduction. So welcome to the lab. So this lab is supposed to help you kind of link the stuff you're learning in lecture. Unfortunately, you can't do the reactions yourself, so that's kind of boring, and you'll have to watch these videos. But it's better than nothing, I would say. So how lab will work, you'll come in each week, and you'll just listen to maybe maybe half an hour, 15 to half an hour of like a lecture, and then I'll give you the background of the lab and what you are expected to know and what to do, so you're not lost. And this is the opportunity to ask me questions in case you can't make it to my office hours. So lab will work that way. And once you complete the online portion, you'll have a week to complete and turn in the post lab, which is on Canvas. And just know that the due dates for those assignments are 1 week from each lab meeting. So for example, the first post lab will be due on next Thursday by midnight. So you'll have to turn it in by then. So I will check the timestamp of when you guys submit the assignment. So if it's past the due date, you'll get docked a few points. So make sure you're on top of things and you don't let that happen. My office hours, they're on Canvas, but they're Mondays and Thursdays from 2 to 3 p.m. My email, my email is actually in the syllabus, so you need to get my email. Just read the syllabus because I'm the head TA also, so my email is there. I'll try to prioritize you guys because you're my section, but I get lots of emails. So if you can't find the answer on Canvas or Piazza, your last resort is probably to email me. But you can also email me about the lab. So is there anything else? Introductions. Nice to meet you all. Sadly, we can't meet face to face, but hope you're all staying safe and engaged in your studies. Is there any questions about Gradescope or how to submit stuff online? All right. If there is a question, just raise your hand. Put the raise your hand function or post something in the chat, and I'll get to it. But if there's nothing more, we're going to continue on with the our next item in the list. So if you can't make it to any of these meetings, the reason has to be like there's a time conflict. It can't be like you overslept. That won't be acceptable. So don't do that. But if you're in like a different country or a different time zone, that's perfectly fine. Everything will be recorded, and so you can see this this presentation on Canvas. So you can always find recordings in the Zoom tab for cloud meetings. So I'll publish these recordings. However, I'll also post these in discussions. So if you go to discussions on Canvas and look for A22, the section, you'll find these recordings. And I'll probably post these lecture slides as well. Okay, so let's talk about safety. So we're going to go over the safety website and just do it like a little tutorial. So hopefully it's not that long. It didn't seem that long when I looked at it. So, but to access these sites, you need to go to Canvas, and you need to make sure you're kind of up to date with the course, because if you fall behind in the course, you can't access it. So it's pretty, leaving set it up so that you guys don't fall behind, which is pretty smart, because the class I taught in the fall, students easily fell behind. So during online learning has its own challenges. Okay, so let's move forward. So we're going to first talk about safety. Even though we're not doing these things in the lab, we must, it's part of the protocol that you guys all know what's safe behavior and what's not safe behavior. So we're going to go look at this safety activity right here. So I'm going to click on this. So I'm going to do a new share. So let's go back to Canvas. Okay, so here, this is my view. Of course, you guys don't get this view because you're not a TA. So if we go all the way down to week 2, hopefully everyone did the pre-lab quiz, because you can't access these videos if you don't do it. So make sure you're up to date with the pre-lab quiz. To prepare for pre-lab quizzes, just read the lab manual. So the lab manual can be found right here. So just read the experiment and give your best shot at the pre-lab quiz. They're only 5 points, and so they're not going to be worth much for the grade. So I wouldn't stress out if you got like a 4 out of 5. They're a very small amount of points, because each lab is worth like over 10 or 20 points. So there's lots of points to obtain from the post lab. So you should always focus on the post lab. But to prepare, just read the lab manual. All the answers should be there. Okay, so we're going to click on this lab safety rules. So let's do that right now. So here is the website. So I've been hearing problems with the videos. So if you have a problem watching the video, make sure you have cookies turned on, and your cache is cleared. I wouldn't watch it on your phone, because if you try to watch on like your iPhone, you'll have to go to the Google Drive or something, and you may have to download it. So I think it's better if you just use your computer and your browser. Safari works fine for me, but if there are problems, let us know. If it's not a simple cache or cookie issue, then you'll probably have to contact Canvas support or IT support, unfortunately, but hopefully no one has to do that. Okay, so we just start. Thanks to the dispensary and Dr. Levens for and everyone else involved at the dispensary helped create the site. So we're going, the rundown is you just navigate through the pages, read it, and then watch the video. So let's play this video right now. So these are going over the safety guidelines that I would normally go over with you in lecture. So this is kind of make this as realistic as possible. So let's give it a watch. Okay.
UC Davis Department of Chemistry Standard Operating Procedure. Safety rules for teaching laboratories. The following rules are designed for your safety in the laboratory. The laboratory instructor, the teaching assistant, laboratory supervisor, and/or course instructor is required to enforce these rules and has the full backing of the Department of Chemistry, staff, and faculty. The lab instructor is also required to enforce all laboratory experiment-specific safety procedures in carrying out the laboratory work. Violations of these rules will result in expulsion from the laboratory. No one is allowed in the laboratory without the supervision of a lab instructor. No laboratory work will be done without supervision. Perform only authorized experiments and only in the manner instructed. Do not alter experimental procedures except as instructed. Specific permission from your lab instructor is required before you may work in any laboratory section other than the one for which you have been assigned. Only laboratory rooms where the same laboratory force is operating may be used for this purpose. If you have a special health condition, asthma, pregnancy, etc., or any personal health concerns, consult your medical professional before taking the chemistry lab. If you come to the laboratory with non-compliant goggles, shoes, or clothing, you will not be allowed to work in the laboratory. In that context, there are no makeup laboratories. Your course grade will be significantly lowered, and you may fail the course if you do not meet the lab attire requirement. A 100% cotton lab coats are required. Approved safety goggles must be worn at all times. At no time are safety glasses of any kind acceptable in the laboratory. Safety goggles may not be modified in any manner. Clothing that completely covers the legs, including the skin between the top of the shoe and the bottom of the pant leg, must be worn at all times in the laboratory. Tights or leggings are not suitable leg coverings. Inadequate protection often leads to injury. Avoid wearing expensive clothes to lab as it may get damaged. Closed-toed, closed-heel shoes that completely cover the entire foot must be worn at all times. Confine long hair while in the lab. All students must have a full-length white cotton lab coat. It cannot be a short chronological lab coat. It must be full-length. The sleeves should not extend past my hand, nor be too short to show my wrists. When I hold them down the side, they should not go past my hand. Also, you must wear safety goggles. These are safety glasses. If you have long hair, it must be pinned up. And you must wear closed-toed shoes and pants or pants equivalents. In my case, I'm wearing a skirt with long boots that are pant equivalent. Nitrile gloves are provided to all students for the air safety labs. Properly fitting gloves is very important. To remove a contaminated glove, place one finger on the inside of the glove, fold it inside out upon itself, place the other finger in, and put the glove inside. We have a nitrile glove recycling program. Place them in the nitrile into the glove recycling bin, not the trash. You must always have one ungloved hand when touching doorknobs or when in the hallway. Horseplay and carelessness are not permitted and are cause for expulsion from the laboratory. You are responsible for everyone's safety. Absolutely no food or drink are to be stored or consumed in the laboratory. Contact lenses and cosmetics, including hand lotions, lip balm, etc., are not to be applied, and medications are not to be consumed while in the laboratory. Personal belongings. Skateboards and other such personal equipment must be stored outside the laboratory. Personal electronics are only permitted when needed for the laboratory. Because cell phones or other personal electronic media can be damaged or contaminated in the laboratory, use of such devices is at the student's own risk.
Okay, that was that video. So now let's go to the next page. So the next thing we would do is go to a question. So these questions are included to help kind of think about what you just watched. Okay, so let's see if we can do this one. So if I have a special health concern, what should you do? Should I not come to class? Consult your instructor? Consult your medical professional? Or D, come to class anyways? Okay, so someone please, text, write in chat, or just maybe, just say it out loud. what do you think the answer is? C, good. I see a lot of C's in the chat. That is correct. So you would not want to come to class anyways, you know. I mean, I'm pretty sensitive. I have like terrible allergic reactions. So I wouldn't want to come to the lab if I knew that I got my allergic reaction could flare up. So the correct answer is consult your medical professional. Correct. So we just choose C and we're good. We just say correct. And then, you know, they have a little explanation of why it's correct and some other advice. So if you ever have a medical condition and you're not sure if you are able to take lab, always consult your doctor first. Okay, let's proceed. Okay, so now we're going to talk about PPE. So you may have heard of PPE in the news a lot because of, you know, the pandemic, but in lab we also wear PPE to protect us. So let's go over the proper you know, protocol to do when in case we have a spill in the lab. So you know, over time you may enter a lab for work or maybe for internship. So it's important to know like what the proper use of PPE is. Okay, so let's watch this video.
Learn the locations and how to operate the nearest eye wash fountain, safety shower, fire extinguisher, and fire alarm box. Basic first aid of any chemicals class is to wash the affected area for at least 10 minutes and seek medical attention. Use the emergency shower, if appropriate, removing contaminated clothing for thorough washing. If the safety shower or eye wash is activated, the exposed person should be accompanied to the Student Health Center for further evaluation. At every sink, there is an eye wash or a soaker hose. To activate the eye wash, simply pull the eye wash to the side. If someone does need to use an eye wash, it's important that the eyes are held open and their face is put down and their face is held down into the water for 15 minutes. That is going to seem like a very, very long time. Water may get all over. That's fine. You'll clean it up after. At each sink, there's also a soaker hose. Pull out the hose, squeeze the handle to turn on the water. This is good. We just need to rinse off an arm or at a low sink to rinse off a leg or foot. To activate the eye wash over here, simply pull back on the lever. Again, we would open the student's eyes, place under the water. To activate the shower, we would pull down on the lever. Water is going to get everywhere. That's fine. We will clean it up after. Remember, if you do need to activate the safety shower, take off as much contaminated clothing as you can, and you need to be in the safety shower for 10 to 15 minutes. Be sure that you've read Safety Net 13 guidelines for chemical spills. For acid spills, we can use sodium bicarbonate solid to clean up spills on the counter. And if you've got acid on your person or your clothing, you can use 5% sodium bicarbonate to neutralize the acid and then rinse with water for 10 to 15 minutes. If there was a base spill, you would use citric acid to clean up spills on the counter, or 5% citric acid solution to rinse clothing or your person, and then rinse for 10 to 15 minutes with copious amounts of water. If you've got bromine or iodine on you, you would use sodium thiosulfate to neutralize the iodine or bromine and then rinse with water for 10 to 15 minutes. And finally, we use 5% acetic acid solution or phenylhydrazine on skin or clothing to neutralize. If there was a large spill of a solvent or water, we have absorbent pads that would be placed on or around the spill to contain it. For spills larger than 500 mils, please notify the lab staff. For any amount of hazardous, be sure to notify the lab staff. Do not try to contain hazardous materials on your own. Every student should have signed up for UC Davis Warning to get notifications for emergencies that are happening on or near campus, site-specific safety orientation, and training. The fire alarms are found at the end of the hallway near the stairwell. To activate the fire alarm, pull down, and this will send a signal to the fire department. In case of emergency, exit the building going down the north stairwell. Going down the north stairwell. Go to the first floor, assemble across the street on the sidewalks. Wait until your TA has taken your attendance. Do not leave until a lab manager has excused you. The fire extinguishers can be found outside every classroom in the hall. In case of an emergency, you will mostly call 911. If need be, pull the pin, point the hose at the bottom of the fire, and squeeze the handle. In most cases, the lab personnel will handle any small fires or will simply call 911. Laboratory doors must remain closed except when individuals are actively entering or exiting the lab. The students must have at least one ungloved hand when outside the laboratory. Gloves are presumed to be contaminated and must not come in contact with anything outside the laboratory except chemical containers. Only use the ungloved hand to open doors, hold onto stair rails, or push elevator buttons.
Okay, so that was talking more about lab safety inside the laboratory. So let's go on to the question they'll ask us. Okay, let's go on. All right, so pop quiz. What do I do if I spill a base on my lab coat sleeve? So there are multiple options here. So let's see what people say. So I don't think it's A. We don't ignore lab spills, so you must use the appropriate reagent. So so since it's a base, I think I want to use acid. So let's see what people have said. A few people. C, D, and F. Okay. C, D, and F. I think people are saying C, D, and F. Okay, C, neutralized with 5% citric acid. That's correct. We use the solution for spills on ourselves or our clothing, because if you just put salt on there, it won't be able to get in contact with the liquid that's like meshed in beneath the surface of the coat. So that's correct. So we would remove contaminated clothes and rinse for at least 10 to 15 minutes. So it should be C, D, and F. So let's check that answer. Okay, good. So whenever we have a spill, we need to report an incident report. So that, so a lot of times I found that students try to hide the accident. So don't do that, especially when people burn themselves. If you burn yourselves in the lab, that's a pretty that's pretty dangerous. So you should get yourself checked out at the student health center. So never hide your injuries. That's not a good thing. Okay, so let's move on to the next part. So hopefully the navigating through this is straightforward. I have been hearing reports about like problems with the videos. So when you guys go to do the assignment, make sure if that does occur, please let us know. Okay. All right, so let's talk about the FUME-HOOD. So this is where you carry out all your chemistry experiments. If you guys took Gen Chem before last year, you probably were working still in the FUME-HOOD. But now these FUME-HOODs don't see any use nowadays. Let's get a summary of how they work. Okay, so let's watch this video. Okay, this one's short.
All activities in which toxic gases or vapors are used or produced must be carried out in the FUME-HOOD. FUME-HOOD safety. When using the FUME-HOOD, do not place your lab notebook inside the FUME-HOOD. Be sure to use the pull-out drawers or the side counters of the outside of the FUME-HOOD. When using the FUME-HOOD, be sure to lift the sacks as high as you need. Never go past into the red zone, and try to think of this as a secondary barrier. To use it to be able to work as low as possible and letting this be your safety barrier. Always work 6 inches inside the FUME-HOOD. In case of an accidental chemical release, close the FUME-HOOD and press the purge button. Once all the fumes have been sucked out, turn the purge off. Sometimes when you first open the FUME-HOODs will alarm. To turn off the alarm, press the silence button. If the alarm keeps going off, please notify the lab dispensary immediately.
Okay, so that's how we would use our FUME-HOODs if we could actually do experiments. Okay, so let's proceed here. Okay. All right, so that's something you should not do. Don't worry, the stuff we use, usually stuff will not catch on fire. All right, so let's talk about chemical hazards and hazardous waste. So, when we use chemicals, there's always some waste that's going to be generated, and it's not always as safe waste. So like the safest waste you could generate is water. Most of the time it's chemicals that are harmful to the environment, so we have to collect it and properly recycle or dispose of it. So let's watch how we collect and dispose of waste generated from our experiments.
Chemical hazards and hazardous waste. Mouth suction must never be used to fill pipettes. Yes, that's the thing. Containers of chemicals may not be taken out of the laboratory except to the dispensary for refill, replacement, or to exchange full waste jugs for empty ones. All containers must be closed with appropriate cap before you take them into the hallway to the dispensary. Always use a safety carrier when transporting chemicals and waste. Put all hazardous waste in the appropriate waste containers provided in your laboratory. Do not overfill waste containers. At the front of the classroom, there are 2 FUME-HOODs. The left FUME-HOOD is where you will find hazardous reagents needed for the class. The right FUME-HOOD is used for waste and acetone rinsing. Be sure to open the lid of the waste and use the funnel to pour out any waste that you need. After you've washed your glassware, you can rinse your glassware with acetone. To dry. Always be sure to cap the bottles when they are not in use. This beaker is only used to hold the funnel. No waste should be in this beaker at any time. If your wastewater becomes full, be sure to get a red carrier. Place the waste in the red carrier and bring it to the dispensary window where our staff will give you a new waste bottle. All chemicals that need to be refilled must be taken to the dispensary in a red safety carrier. All incidents, near misses, injuries, explosions, or fires must be reported at once to the laboratory instructor. In case of serious injury or fire, even if the fire is out, the lab instructor or lab supervisor must call 911. If a student is seeking medical attention, they must always be accompanied to the student health center. No matter how minor the incident, always report it to your lab instructor. Sometimes something that seems like a minor incident, like a cut on a beaker, upon further investigation is found to be a serious incident. Always seek guidance. A lab instructor must always fill out an incident report for any accidents, injuries, explosions, or near misses that occur in the class.
Okay, guys, let's go on to the question now. Waste question. All right, at the end of my lab, I have 10 milliliters of liquid left in the test tube. What should I do with it? Look at the waste container and guess which one it goes in? Ask my teaching assistant? Check my lab manual? Pour it in the drain with lots of water? Put it in my locker until next week. Okay. All right, everyone, what do you think you should do if you don't know where to dispose of said liquid? Right. So if the lab manual doesn't tell you, just you probably should just ask your TA. They'll definitely know where to put the liquid. So a lot of people put C. Okay. So C could probably give you the answer, but I think it's B. So I'm going to choose B. I think B is the answer. Because sometimes the lab manual won't tell you like, oh, if I have this chemical left over somehow, how do I dispose of it? So it might not actually tell you where to dispose of it. Because sometimes procedures change and we generally don't change the general procedure, but like stuff that happens during the lab. So it's better to ask your TA. So I think it's B. Let's check. Oh, so both B and C are correct. So we're all correct. So if you chose C, that is good. So good job. So we are right, referring to the lab manual is best, but if it's still unclear, ask your lab instructor. Okay. So the reason why we don't want to put them in the wrong waste container, because some chemicals react with each other, and if they produce a lot of heat, it can cause an explosion. So that's one of the reasons why we always design these experiments to be as green as possible, or to be as friendly as possible to the people doing the experiments and to the environment from which the energy must escape and go back to the atmosphere. So we're always looking to improve upon what other people have found in the past. So we're always trying to make reactions more compatible. So if you ever have questions about lab waste, always refer to the manual or ask your TA. Don't just assume anything. That could be disastrous. So we do not want to assume anything in the chemistry lab. Okay. Only if instructed by, say, myself or the instructor can a substance go down the drain. And usually it has to be something very safe, or like water, something like that degrades like biochemically. So stuff like sulfuric acid, or like phenylhydrazines, toxic organic compounds, we do never go down the drain. And when we do draw down the drain, we must rinse it with lots of water so it doesn't damage the pipes. Okay, so let's proceed. Okay, so now let's talk about good science. So this is about lab etiquette. So if we were actually doing labs, I would usually give points for participation or lab etiquette or cleanup. If you're a good lab student, you would get like extra few points at the end of the quarter from me. But of course, that does not apply anymore because we're no longer in the lab. But this is because some students are just naturally messy, and they're always rushing, so they don't really think about other students who use the same lab space. So make sure you're kind of aware of that when you doing the experiments whenever you go work in the lab. Okay, so let's watch the video right here. So these are going to demonstrate the lockers that you would have been using. So here we go.
A clean workspace is good science. Keep your working area clean. Immediately clean up all spills or broken glass. Dispose of sharps in their appropriate container. Do not dispose of pipette tips in the regular trash. Clean off your lab workbench before leaving the laboratory. If you break something, use the dustpan and broom to clean up the glass, and then pour it into the broken glass container. If the broken glass container is full, please notify the lab staff. The general solvents in the lazy season on the counters. We have dilute acids, solid salts, saturated salts, and dilute base, and several different solvents. Do not place your lab notebooks on the chemical counters. If you need ice, you will get it for your whole class. There's a large black bucket under the sink in your classroom, and across from the dispensary is the ice machine. Use the scoopula or pan to scoop out the ice. And when you're done, please be sure to place the pan on top and close the ice machine. You must sign the safety acknowledgement sheet before you may work in the lab. If you have questions about these rules and procedures, please ask the lab instructor before starting any laboratory work. Next, you will check into your locker. Your locker series may not match your section series. Please refer to the safety acknowledgement sheet to see what locker series you are assigned to. Locker numbers are the room number, the locker series, and the drawer number. You will be provided with a locker list. Ensure that all items are present, in good condition, and clean. Come to the dispensary for missing or broken items. On the first day and the first day only, we will replace all dirty glassware. After that, it is your responsibility to ensure all glassware is clean. Then optimize the placement of the locker items by arranging them as in the picture. You'll be assigned to a locker. The locker series numbers go room number, your series number, and then your individual locker number. I'm assigned to section 2, locker 22, in room 3359. When you first come in, you'll be given a chemistry locker list. Be sure that you have in the locker and then arrange it the way it looks in the picture. Some lockers are not found in the general vicinity of your FUME-HOOD, and you may need to get your locker from one of the other counters or side counters. In that case, you'll take your locker and place it in the open cubby hole. At the end of class, you must return the locker to where you found it. They are not interchangeable through different levels and different locations. Okay. Place your lab coat and goggles in a plastic bag with your name and section number. Store it in the bin with the same locker series number. Note, this may be different from your class section number. At the end of lab, take off your safety goggles and your lab coat. Place them in your plastic bag with your name and your section number on them in the bin that is the same as your section. This film was brought to you by University of California, Davis Department of Chemistry, produced by Jillian Emerson, Ashna Prashad, and Roxanne Urena.
Okay, I think that's the end, but let's proceed. So whenever you finish one of these activities, you'll be brought to a screen like this. And to receive credit and to know that you've done it and that you haven't gotten the answers from someone else, I need you to click on this link right here. So, after we're done here, we have time, just go through the safety discussion again and just make sure you press this receive credit for the lab. Or if you're doing it now, that's fine too, since we're doing this as a class. So make sure for this experiment, we're not going to be giving you any data for you to guys to analyze. So that'll happen probably with next week's experiment. But what's expected is that after you've done this activity, you take the post-lab sheet and you complete it. So those post-lab sheets are what will be graded for lab. So you're expected to complete the post-lab sheet, turn it in on Gradescope, and then just do it before the deadline, which is a week. You'll have a week to complete it, and you'll have until Thursdays at midnight to submit it the following week. So we just click this tab here, and that's it. You will just sign your name. I'll just sign my name just so we get the hang of this. And we just go to our section, A22. And you could just say, send a copy of my responses. So it's important that you're signed into Google, your Google account, so your UC Davis account. If you're not signed in, you won't have access to the site. So so don't use your personal Gmail or personal Hotmail account. Use your UC Davis email address when you're accessing these sites. So make sure you're signed on. And do not use incognito or anything. Incognito mode on Firefox or Chrome or anything. It won't work. So don't do that. So let's submit. Then we're done. Okay. So that is safety, guys, everyone. So please complete the safety assignment. Make sure you click that button at the end to receive credit. So we all, you are all on record to have agreeing and being introduced to the safety guidelines. So that's a requirement for all the lab classes. Even though we're on a remote, remote format, we still have to make sure you guys been instructed about proper safety. So when you go into a lab, you know how to practice and be safe while carrying out, science. Okay, so that's safety. Let's close that. Let's go back to the PowerPoint. So this one right here. Okay, so I'm just going to talk for 10 minutes about the introduction of what you'll be doing this week. So experiment 1, we're going to be looking at molecular models. So hopefully if you have your model kits, that'll be great. If you don't have a model kit, you can actually you can do the experiment, but it might be kind of hard to visualize. So if you're having trouble, let me know. I know a few resources online that can maybe help in that area for visualizing stuff. So if you need to see a visual aid, let me know. So we're going to talk about experiment 1, molecular models. So last quarter in 8A, you've seen these molecules, but you haven't really actually played and probably haven't actually built them, or maybe you have, but haven't, maybe explored in a lot of depth. So we use these models. So what is a model? Well, a model is a representation of something. So we usually use models. Yeah, I could give you the link. Hold on, let me put it in the chat. So the link is, so if you want to use the link, let's go back to here. So if we go back to, so it's called Otterbein symmetry. So in this site, you can actually go to, so I'm gonna just, so if you go to gallery, so I'll put it right here in the chat. So you go to gallery, you can actually look at compounds. So you should do molecule type, and you look for organic, and it lists all the organic compounds. So one compound we're going to go over is methane. So here's methane, and it also gives you the chair forms for cyclohexane. So that's cool. So stuff like this. So you can actually visualize the chair structure without having to build it. That's probably a little bit easier. And if you don't want to use a visual aid like this, you can build your models using marshmallows and toothpicks, but I'm not sure if people have like a ton of marshmallows unless you really love s'mores. But that's also an option. You don't have to use the model kits. You can use your own models, makeshift from home. But this site is also very helpful if you don't have access to any of the materials. So for example, you can utilize this site and look at these models, see methane, you can visualize the rotations. So I wouldn't worry too much about this. What I would worry about is probably the CT rotations, which will probably be involved in your post lab. But you see here, if we bisect one of the angles and we rotate it 180 degrees, we get the same molecule. So that's called a symmetry operation. And molecules, they possess symmetry elements like these. Okay, so that is the website. I linked it in there to help you with the post lab. You can use it to help guide you through the post lab. But make sure you work on these post labs yourself. I mean, you could probably work through the assignments together, but you need to submit your own work. So if I see two assignments that are like same word for word in the same coordinate on your paper, same space on the piece of paper, that'll be grounds for me to flag it, and I don't want to do that. When this whole pandemic and we caught a lot of people, doing dishonest work and like homework and stuff, and we unfortunately had to report it. So always make sure you do your own work for the post labs, for everything in the class. You do not want to be referred to SJA. That's happened. I've had to do that for a number of students in the OChem series, so I don't want to do that for my own students. So please always submit your own work. But anyway, enough of that discipline like talk. Let's go back now to what we were talking about earlier. Okay, so I promise this won't be long. Okay, so we have models because we can't really see these atoms, right? So we need models to help us visualize, and these models are always based on experimental data. So we can't be like, oh, I think it looks like this light bulb, so I'm going to use a light bulb to represent this atom. Well, you can't really say that if there's no evidence, because it's like it's like claiming fake news. If you don't have no evidence, how can you say that it's true or anything, right? So you really need something to back it up. So the most common models we use are ball and stick. So like the ones you've seen in the model kits, and I'll show you in a minute what they look like. And space filling. Space filling is less common, but they are used to like represent like proteins and stuff, because in proteins there are a lot of atoms, and it's really complicated if you show the ball and stick model, because it gets a little bit messy when visualizing it. So the most common ones we know are, the ones we draw on paper in your OChem exams, OChem homework, the plastic models we build, and these are the models we commonly see in computer programs, thanks to people who've developed technology to help us study chemistry. So this is space filling, and this is kind of representing what these atoms mean. So the different colored atoms represent an element. Gray or black is usually carbon, and then I'm just reading the chat a bit. Sorry for the pause. So yes, you may watch the video later. It's all being recorded, so it'll be available. So don't worry if you have to leave early. I know everyone's in a different time zone. So these are the type of models we kind of use. So let's go over now, like the kind of shapes that we're seeing in organic. So we've talked about these. So this is like an example of a model kit you would use. So right here, carbon, hydrogen, nitrogen is blue. Oxygen is commonly always red. That's just a thing for models. And then, the assignment's going to have you review electron pair geometry and remember what sp3, sp2, and sp hybridizations are. So remember, they're based on the arrangement of electron pairs around a central atom, based on electron pairs tending to repulse each other. So they'll form shapes that have the maximum distance between electron groups. And the electron pair angle tells us what kind of geometry it likes to adopt. So this might be all familiar from 8A, from Chem 2, where we talked about a lot of geometries, but the geometry in organic chemistry, we only care about the tetrahedral geometries. So the sp3, sp, and sp2. We do not necessarily care about transition metal geometries. That's more like of a general chemistry topic, and inorganic. So if any of you ever go to inorganic, which I think people in dentistry might have to do, that is those kind of geometries are seen in inorganic compounds, or like transition metal complexes or compounds that you learn probably in 2C. Okay, and anyway, so remember the three common geometry types. We have something that's 180 degrees bond angle, 120, and 109.5. So this one should be pretty obvious, and I wouldn't say obvious, but you should be able to connect it right away to what geometry it is. And it is four bonds to the central element. So we have a tetrahedral geometry. Okay. So this is just a background about the common geometries, some information you may have forgotten. So if I have a central atom in the middle, let's say here, I have two electron groups around it, 1, 2. If you look at this atom, 1, 2. So this geometry is linear because it looks like a line. And the bond angle of a line is always 180 degrees. And then when we have something like this, a triple bond, we have 2 sigma bonds because there's one here, one single bond, and a single bond here. For triple bonds, we will have 2 pi bonds because we have a double and then a triple bond. So those electrons form pi bonds and not sigma bonds. So maybe that's a little refresher if you guys kind of forgot. I think they'll talk about it in the activity, so we're just going over this really briefly. So if we have 3 regions of electron density, here's our central atom. For example, in acetone, this is acetone right here. So if I look at my central atom, I have 3 electron groups around it. Now, the inclusion of a double bond actually is important when we talk about, say, like these two molecules here. So you see in this molecule, they look the same, but they're different. So one of them has the chlorine on the same side of the double bond, while this molecule has the chlorine on opposite sides of the double bond. So you may think, well, Andrew, can't I just rotate one of those chlorine atoms to the other side? Then it'll be the same molecule. Well, that would be true if this was a single bond. But the fact the pi bond is always, above the axis, so it kind of restricts rotation because it's not between the nuclei of the two atoms. It's above and below the single bond. So that bond above and below right here that comprises the double bond, that prevents free rotation. So you'll never see so that's why these molecules have different properties, is because they're not the same compound, and you can't freely rotate around a double bond. So you can't, they will be 2 different compounds. But anyway, we have our geometry as trigonal planar. That may sound familiar. And usually we say this geometry is sp2 because it's trigonal planar. The previous one is sp. And the bond angle is 120 degrees. So this is approximately 120 degrees. And this is not drawn to scale, so don't confuse. But it's better to look at this model, 120, 120, 120. And see, when we have a double bond, now we have 3 single bonds, 1, 2, 3. And then 1 double bond means we have 1 pi bond. Okay, I think I meant to say 1 pi bond. Sorry, that's a typo. I will fix that before I post this. That should be 1 pi bond. So if you got the number of bonds right, is because carbon can only form 4 bonds. So this is actually incorrect. That should be 1 pi bond. Sorry about that. Okay, so that's sp2. Okay, now we have sp3. The most common geometry, you probably heard of it, tetrahedral. Lots of molecules will have the tetrahedral geometry. So we have 4 regions of electron density. So if I choose any carbon atom here, right here, I'll see that I have 4 electron groups, 1, 2, 3, 4, 1, 2, 3, 4, etc. And if I look at one of these, 1, 2, 3, 4 electron groups around it. So electron group can be a bond or a lone pair. So for example, oxygen, it'll have 2 bonds, but also has 2 pairs of lone pair. It has 2 pairs of electrons as lone pairs. So it's actually 1, 2, 3, 4. So oxygen can be considered sp3 hybridized and tetrahedral too. So the bond angle is 109.5 degrees, and we have 4 sigma bonds and no pi bonds because when we have sp3 hybridization, we made new orbitals with all the p orbitals. So now we can't use any of the p orbitals to form double or triple bonds. So remember, pi bonds form from overlap of adjacent p orbitals. So if we don't have any p orbitals left, we can't use that for pi bonds. So in this case, we have 0 pi bonds. Okay. Are there any questions about what we went over? Hopefully this kind of reminds people of what they learned in 8A. So this is just meant to be like a little refresher experiment. So hopefully it's not too new or it's not too confusing right now. Okay, let's go on. So remember, so you may have learned about conformations. So remember, like conformations and chair structures. We're going to talk about conformations. See if we compare ethane and ethylene. Remember, we can't freely rotate this bond because of the double bond. So if you were to build these molecules, you'll see that you can't really twist them, and that's because the double bond adds that kind of restriction of rotation. And so ethane, however, if you build a molecule of ethane, you could easily twist them around and see that they're always instantaneously rotating at a given temperature. Whereas ethylene, you'll never see it rotate. You'll always see it in this form, unless you cause some other change, which is not what we're looking at right now. Okay, so it's good to think about these rotations because remember in chemistry, molecules are never stagnant. They're never always staying in one like conformation, especially when you have rotation. There's always going to be like, when they're at a certain temperature, you're going to be at like a eclipse conformation or a gauche conformation or a staggered conformation. So actually, these rotations are important when you're thinking about chemical reactions and why some reactions occur readily and why others don't. But that's probably something more of an AA topic. This is just more like for review. Okay. So you're going to be building chair cyclohexanes. So you're going to visualize like what we actually taught you, that like this planar structure of a cyclohexane is actually not the most stable, and you'll actually see you building the chair conformation, okay, and explaining like why is it important, and is it really the most stable conformation. So you'll be visualizing chairs, boats, and you'll be confirming which one is the most stable and which one is the least stable. So for example, we all know, right, that the chair structure is the most stable form of the molecule. And that's because if you were to look down a CC bond, you'll see that all these hydrogens are in the staggered conformation. And that's confirmed if you ever build a chair structure. So I encourage you all to build the chair and confirm this for yourself. And if you build the boat, you'll have some eclipsing interactions along, as well as like hydrogen transannular strain, which is when these two hydrogens, they kind of come close together in the boat structure. So you'll build chairs and you'll answer questions about that. Then lastly, well, this is just a summary of all the types of bonds in organic chemistry, or basically their hybridizations and like what type of bonds form. You see that like hydrogen and halogens, they only form one bond. They don't like to form multiple bonds in compounds. And then oxygen will never form a triple bond. That's way too unstable. So it likes double bonds or two bonds to oxygen. And nitrogen likes everything, so it'll be 3, 2, or 2 groups, then triple bond as well. So triple, double, single. So nitrogen is able to adopt many different types of bonding in its compounds. Okay. So we went over tetrahedral, trigonoplanar, linear. Those are the geometries you are expected to know and to think about when you're looking at these shapes in the post lab and on the online activity. Lastly, we're going to talk about chirality because we're going to review that. So if you're ever confused by chirality, make sure you review it. It's a topic that always come up. You have to think about like what's a chiral center, how do we change chiral centers, when do they change, and when they don't change in reactions. So that's a big part of drawing the correct product. So I would always be thinking about this, and if you forgot, please review. It's a very tough subject in chemistry. So remember, chiral compounds are compounds with a carbon that has 4 different substituents. So in this ring structure, we see that both sides of the rings are not equivalent. So these are 2 different substituents, and this is not the same, and this is not the same. So here we have a stereo center right here, and then we draw its mirror image. Pretend a mirror is right here and mirror the image back. We see that if we were to rotate the one on the left, it will not match up with the one on the right because everything will line up, but this H now will be wedged over here, and this alkyl group will be dashed, and it will not match the enantiomer here. So those are called enantiomers or non-superimposable mirror images, and those are a kind of stereoisomers. So be familiar to identify chiral centers, chiral compounds, and R or S. So you need a reminder of R and S. Make sure you practice that. It'll be a nomenclature Lebens likes to give stereocenters. So you'll be required to know how to assign R and S again for new types of compounds that you'll be introduced to. So don't forget R and S. RNS is going to be really confusing when we talk about sugars, because there's a whole different class of designation for like D and L sugars. But so it's important that you kind of have these concepts of chiral RNS designations. You kind of mastered it. So here is alanine. See how they are mirror images as well. So one is R alanine and one is S alanine. And see, if we try to flip it over to this mirror image, they do not line up. So they're also enantiomers. So you'll have to identify enantiomers in the activity. And lastly, we'll talk about meso compounds. So meso compounds are compounds that have more than one chiral center. That's by definition. And if you have a meso compound, it may have chiral centers, but it's overall optically inactive. So it has no optical activity, and that's because it has an internal mirror plane. So that mirror plane is a symmetry element. And if a molecule has any kind of symmetry element that makes parts of the molecule equal, it cannot reflect light. It cannot interact with plane polarized light, which is the definition for chirality. So chiral compounds, they interact with plane polarized light in different ways. That's why they are different compounds. But if we have a symmetry element, there's no way that this molecule could interact with that light differently from its enantiomer. And in fact, when you have meso compound, if you think it's an enantiomer, it's the same compound because it has a mirror plane. And so because of that mirror plane, we have a meso compound. So it has chiral centers, right here. These are chiral centers, but overall the molecule is asymmetric or achiral. So it has no chiral character. Okay, so the last part of the experiment, you'll look at a compound similar to this, and it'll ask you about the meso compound. Okay, so that is experiment 1 in a nutshell. So what we'll do, so make sure you take the pre-lab, because if you don't, so if we open this activity and we go back to Canvas, we see here it'll link us back to the activity, which is week 2 lab. So here's the lab you'll select, but if you don't do the pre-lab quiz, you won't have access to it. So make sure you do that first. So you click on the experiment and it'll tell you the objectives you're expected to know, which I kind of went over briefly. And then you just click start. Make sure you go through every bit of the activity and click receive credit at the end. So, and submit the Google form to know that so that it lets me know that you did the online activity and you're good to go. So if you don't do the online activity, I think I'll have to mark you down, and we'll have to discuss what happened. So make sure you do the online activity first, then go to the post lab. So you need to complete both to receive credit for the lab. So you only do one, you won't receive credit for the lab, and it won't count. So I had a question: when is the online activity due? So you should really just do it first. So you'll have a week. So it's probably going to be due when the post lab is due. So you'll have a week to complete the experiment, the online activity for the experiment, and the post lab that goes along with it. So you have a week. So try to stick to a schedule. Don't fall behind. You don't want to do these things last minute. That's how points are lost. So I don't. And but there's a quiz. Today is Thursday, right? There's a quiz tomorrow, so I probably wouldn't focus on this right now. It's probably not as important. So just focus on studying for the quiz tomorrow. But anyway, guys, that's it. Good luck. Any questions, let me know. I'm here for a few more minutes. If there's no questions, I'm just going to head on off as everyone leaves.
I just had a quick question on, you might have said this since I did come a little bit late, but if we open these Google forms, can we exit out and come back, or do we have to do it in one sit, one shot?
Oh, I think you can still access it as long as you, but I think you have to still put in your answers again to proceed. So it might be best to just do it in one sitting if you can.
Okay. Okay. Thank you.
Mm-hmm.
If we get questions wrong on the activity, will we be docked points?
No, so it'll actually tell you to go watch it again, the video, and you'll have another chance to get it right. So it won't let you move forward until you I think answered it correctly.
Oh, okay. No. Also, so I know we're supposed to attend here, right? There's a panel for my internship that like I would like to attend that's next Thursday, and it does overlap with this lab time. So would I be able to watch the recording, or is like attendance like mandatory?
So that's perfectly fine. I mean, if you have like work or something related, that's fine. That's a valid excuse to watch the recording. So you should be good. It's so you should attend the panel.
Okay, and then do I email you about that, or?
I think I'll remember. I'll take note of it, so I'll know you won't be here next week.
Okay, I don't know. We'll see what happens.
Okay.
Thanks.
Welcome.